Hey guys, first thing we're doing on this FRQ is making a slope field for these 6 points. And when I make a slope field, I like to identify the easy ones, the places where the slope, aka the derivative, equals 0, or the places where the slope does not exist. So I like to do that first. So if I look at this slope field that's given to me, or this differential equation that's given, I'm going to pick out the 0 slopes first. And I can tell that this derivative will equal 0 when the numerator, that y squared, is equal to 0. Or in other words, when y is equal to 0. So I'm going to go through here, and anytime my y is equal to 0, I'm going to have a 0 slope. Cool. And a lot of times you get points for showing those 0 slopes. And I would do my undefined slopes also, and you can see that it would be when the denominator equals 0, when x equals 1, but they left all of those blank on our slope field, so I don't have to worry about it. All right, so the next thing I'm going to do is find the other 4 points. So I'll find the slope when x equals 0, y equals 1, so this dot here at 0, 1. And the slope there, dy dx, would equal, well, let's see, y is 1, so it's 1 squared over 0 minus 1, negative 1. So I'm going to put a little slope of negative 1 there. And then up next, let's get the point 0, 2. So that would look like 2 for y, so y squared would be 4. So it looks like a slope of negative 4. So it's going to be steeper, a lot steeper. Now they're not looking for exact on the AP test, they're just looking for, in relation to that other slope, is it more steep? Cool. So up next, I'll do the point 2, 1. All right, and that means my y is going to be 1, so it's going to be a 1 squared in the numerator, and then 2 minus 1 in the denominator, so a slope of 1. That looks like about 1. Good enough. And then I'll do the point 2, 2. So 2 in the for y would make the numerator 2 squared, or 4. And then the denominator would be 2 minus 1. And so we're looking for a slope of 4. So in relation to the last slope that I did, this one needs to be more steep. Cool. All right, so for part A, that's all I had to do. Honestly, part A was probably worth 2 points. If you don't believe me, you can go look at the scoring guidelines. They probably gave 1 point for the 0 slopes and a 2nd point for the other slopes in relation to each other. All right, on part B, it says let f of x be the particular solution with the initial condition 2, 3. Write an equation for the tangent line. Okay, tangent lines are always good to do with differential equations because you already know how to find your slope. You know that your slope of that tangent line, your slope is given to you by dy dx, and it's at 2, 3. So I'll replace the y with a 3. I'll replace the x with a 2. So it looks like a 9 over 1. So my slope is 9. At this point, my dy dx, my slope, is 9. M equals 9. So usually you get a point for the slope. And then now we'll write the equation of the tangent line. So remember to write an equation of a tangent line. This is all for part B. To write an equation of a tangent line, we're going to use point slope form. So y minus y1 equals m times x minus x1. Cool. There's the equation of my tangent line. And you'd either get a point for the slope or a point for the whole tangent line, probably one or the other. And then your other point would come from approximating f of 2.1. So approximating when x equals 2.1. So plugging a 2.1 in for x and doing the math. So 2.1 minus, that's 0.1, y minus 3 equals 0.9. Add 3 to that, y equals 3.9. So that's where you would get your other point. I don't know exactly where your first point would have come from, one of those two, and then your second point from the approximation. So we're up to like 4 points in this FRQ already, and the most important part is part C, where we're going to actually solve the differential equation. So I'm going to give myself some room to solve this. Let's make this smaller. dy dx. Now the points for this, the first point usually comes from separating, so let's make sure we do it right. I need to move the y squared to the other side using division, so 1 over y squared. I need to move my dx to the right side, so we'll multiply that dx to the right side. All right, so usually you get 1 point for the separation, and usually just 1 point for the integration. So the antiderivative, 1 over y, you know what? I'm going to rewrite this first. It's not a natural log because it's a y squared in the denominator. I'm going to rewrite it like this. And then I'm going to use my reverse power rule. So that's my n plus 1 rule. So y to the negative first over negative 1. And then I'll integrate the other side. Now this is a natural log because the denominator is to the first power. So I could use a natural log on that side. When you do the natural log, make sure that the derivative of your baby, the inner part, you think about it. And the derivative of that inner part is just 1, so there's not much to think about. So I'll rewrite this part as negative 1 over y is natural log of x minus 1 plus c. Cool, cool. Move that negative over. And let's reciprocate. Y equals 1 over natural log of x minus 1 c. Cool, cool. So there's our general solution, but we did want a particular solution that passes through the point, 2, 3. So I am going to have to plug that 2 and 3 in for the x and the y and figure out what c is. So I'm going to, again, make my things smaller here. So we're going to replace the y with 3. We're going to replace x with 2. And I know you could have solved for c at other places, but I usually just do it at the end. Natural log of 1 is just 0. So really this just says 3 equals negative 1 over c. Let's solve this for c real quick. Move the negative over. Do the reciprocal. All right, so now that I know what c is, I can get my particular solution. My general solution was up here. So it was y equals negative 1 over natural log of x minus 1. Now instead of plus c, I can drop in that minus 1/3. And there's my particular solution. All right, so hopefully I got a 9 out of 9 on this FRQ. I'll definitely check my work before I post this, but that's how you do it. Easy money.